So welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom video with me, Coach Good. This is the last notes for Unit 9. Oh boy, Unit 9. Notes number, who knows?
9.
6. Wow, you're way off. Notes number 6. And this is going to be transformations of logarithmic functions. We're on the blank side, the completely blank side. Yeah, so, we've seen transformations many a time already. We just did them last week again, and now we're doing them again. But this time we're doing it on logarithmic functions. So, we're going to make a table on the front side here. Don't take the whole piece of paper. I would take maybe a little over half of this table or something like that, because we still do need to write examples. So, there's going to be 3 columns. The first column is going to say transformation. The middle column will say general notation. And the last column is going to say examples. That's a decently straight line. All right. All right, so what we're going to do is I'm going to give you the examples, and I'm going to see if you can guess what happens to the graph, how the examples change the original graph. That way you can apply your brains a little bit, you feel me? All right, so let's write these examples down. Y equals log of x plus 3. Also, we're going to write y equals log of x minus 4. Then I'm going to put a separating line here. Hey, oh, that was I don't know. All right, y equals log of, in parentheses, x minus 2. Next, y equals log of, in parentheses, x plus 1. And these are going to be the first examples that we look at. All right, so on the top right there where it says y equals log of x plus 3, what do you think that plus 3 would do to the parent function graph? Up 3, that is correct. And what do you think the minus 4 would do then? Down 4, that's right. So this transformation is going to be vertical translation. Remember, translation just means the shifting. All right, so also I want you to notice, though, in our examples right over there on the right side, it's very specific. It shows you a certain type of function, right? It shows you the logarithmic function, and then it's showing you like plus 3. That's a specific number. I chose that number. But there's a general notation that's pretty much like basically the rule for any type of function. So for example, if I write, watch this, if I write f of x plus k, this is a general rule for vertical translations for any type of function. F of x you just replace with whatever parent function you're working with, and then k just means you're adding any number. It can be positive or negative, and that's going to show a shift up or down in any function. So that's a general notation. All right, so let's look at the next examples then. Y equals log of, in parentheses, x minus 2. How would that change from the original graph? Right 2, very good. And so what would the plus 1 change from the original graph? What? Left 1, that's right. So this is going to be, instead of a vertical translation, it's going to be a, that's right, horizontal translation. Oh. And the general notation for horizontal translation is going to be f, and then in parentheses, x minus h. Like this. Notice always when we have a horizontal translation, you're subtracting a number from x. That's what we think of as the inside. But really, you're just subtracting a number from x. All right, for our next group of examples, we're going to write this. Y equals 6 times log of x. Y equals 1/2 times log of x. By the way, what is the base on all of these examples I've shown you so far?
10.
That's right, it's 10. There we go, that's better. All right, and then we're also going to write y equals log of 1/5 times x and y equals log of 3 times x. Okay, so when you look at the y equals 6 times log of x, how do you think that differentiates from the original graph? So what is that transformation called then? What do you think the transformation is going to be? Vertical stretch by?
6.
That's right. And so then what would the 1/2 do in the 1/2 log of x? Exactly. So this is going to show a vertical stretch or shrink. And remember, some other words for stretch and shrink would be like expand, expansion, compression, things like that. And the general notation for this that would apply for any function would be if you take the function f of x and you multiply the whole function by a number, we call it a. Right? Notice every time when there's a vertical stretch or shrink, you're just multiplying the whole function by a number. All right, what about our next example where it says y equals log of 1/5 times x? What do you think that is?
Horizontal stretch.
Which one?
Stretch.
By? 5. That's right, that's right. So the 1/5x is going to be a horizontal stretch by 5. So then what would the 3 be, the log of 3x? Horizontal shrink by 1/3, that's right. So this is going to be a horizontal... Gasp. Horizontal stretch or shrink. That looks like an N. Horizontal stretch or shrink, and the general notation for this is going to be f of 1/b. That tells you that it's going to be the reciprocal. That's why you know the 1/b tells you that you have to take the reciprocal, and that's going to give you your stretch or shrink. 1/b times x. Like this. That's why we know that the 1/5 is actually a stretch by 5. That's why we know that the 3 is actually 1/3, that's a shrink. Okay, and last examples is going to be y equals negative log of x and y equals log of negative x. Okay, so with the y equals negative log of x with the negative sign out in front, what do you think that does? Reflect over the x-axis, that's right. And what do you think that the negative that's being applied to just the x does? Reflect over y, that's right. So this is going to be a reflection over x or y-axis. So reflection over the x or y-axis, and the general notation for this is going to be when you have the negative function. So we're applying the negative sign to the whole function, or we have f of just negative x. Pause. All right, so with transformations, remember there's always 3 different types of problems we're working with. First, there's where we just state the transformations based on looking at equation. Then there's where we write an equation based on transformations given to us. And then there's graphing. So we're going to go into some examples now. So the first example set is going to be example set number 1. And we're just going to state, okay, the transformations. And our first example is going to say f of x equals 1/2 log base 2 of x plus 4. Okay, I'm not sure if you guys will remember this or not, but the base, right, what's the base here? 2. That does not signal a transformation, right? The base is just there, and it will just change your starting points, right, of the parent function. Because remember, the parent function for log and exponential, you need a base, right? And that base only changes your starting points, but it doesn't do anything for transformations, all right? So there's only 2 transformations here. So what we're going to do is we're going to have somebody tell us one of the transformations, and when you give me one of the answers, You cannot answer again. We're going to get a bunch of different people to answer. So who wants to do the first transformation here? Alejandro.
Vertical shrink.
Vertical shrink by?
1.
That's right. Vertical shrink by 1/2. That's what the 1/2 tells you. Thank you. Who wants to do the next transformation here? Madison?
It's a local translation.
In what way?
Forward.
If it's horizontal,
Oh, it's left.
left. Left 4. That's right. Good. All right. That's the first one. So Madison and Alejandro, you guys are done. Second one, g of x, just for fun. G of x equals negative log base 8 of x plus 5. So who wants to give the first transformation here? Jaime. Reflect over x, that's right. The negative out in front tells us that we're reflecting over the x-axis. Who wants to give the next transformation? Aiden Yetman. Left 5 units, that's right. Good. All right, breezing through this one. And the last example of this type of question, 3, is going to be h of x equals 3 times the log base 3 of x minus 7 plus 4. All right, who will volunteer themselves to give the first transformation? Adelina?
Vertical stretch.
Vertical stretch by? 3, that's right. Vertical stretch by 3. All right. Lacey, can you give me the next transformation here?
Oh. Right 7.
Right 7, that's right. All right, and then what about you, Holly? What about the last one? Up 4, very good. Nice. Good. All right, so that ends our examples of this type. So now we're going to do some examples where we're writing the equation out. All right, pay attention to how the question is written, okay? It's going to tell you f of x, this is the original function, okay? F of x equals log base 4 of x. Why do you think that it would say log base 4 of x in the original? What does that tell you to do? If log base 4 is in the original, then all of your transformations should have a base of. That's right. So pretty much it just tells you that all your transformations, your new function should also have a base of 4. Because you're transforming this function. All right, so then we're going to write g of x when f of x is transformed by, and then here are the problems. So first problem, just one transformation here. Reflected over the y-axis. So can you write g of x when f of x is transformed such that it reflects over the y-axis? Does anybody know what this one would be? Any volunteers?
Log.
How would you start it though at the very beginning before you even write log?
F of x.
Not f of x, that's the original.
Oh, g of x.
G of x,
And then equals log. And then parentheses.
just parentheses. What happened to the base? What's the base?
Oh, 4.
Bless you. Right, log base 4 because our original was log base 4. Okay, and then
Parentheses.
right,
Negative x.
negative x. Perfect. There it is. That negative sign applied to the x tells us that it's being reflected over the y-axis. So you've written the equation correctly. Very good. Next problem then. Number 2, when it is stretched horizontally by 3 and translated up 2 units. Can you give me the equation that would show the original being stretched horizontally by 3 and translated up 2 units? So can somebody tell me how you would show the stretched horizontally by 3? How would I start it off?
G of x equals log 4.
Log base 4?
Yeah. And then parentheses. And then 1/3.
1/3, that's right.
Yeah, or 1/3 x, and then just plus 2 after that.
That's right, plus 2 after that. Very good. So that shows stretched horizontally stretched by 3. It's going to be a 1/3 multiplying x. And then plus 2 shows that we're translated up 2 units. All right. And the last example of this is going to be compressed vertically by 1/2 and shifted left 1 unit. So can somebody different now, let's see somebody else give us the equation here. Who wants to give it a go? Who would like to take a shot?
Is it g of x equals 1/2 log?
1/2, right? The 1/2 at the beginning shows you the vertically compressed by 1/2, okay? Log. So far we're at log. What comes after log?
X plus 1.
Base 4. So Trey throws us the base 4, and then yes, you're right, where it is x plus 1 on the inside of the parentheses. And there it is. Very good. Yeah, so the 1/2 at the beginning shows us the vertically compressed by 1/2, and shifted left means add 1 to the x. All right, so now let's flip the page over. Now we are ready to graph. Okay, so on these examples, okay, I accidentally put the graphs in a weird spot because I thought we'd take more space, but it didn't. So, example 3, we are going to graph f of x, then state then give specified information, which is going to be things like, transformations, asymptote, domain range, that kind of thing. So first example is going to be f of x equals log base 2 of x minus 2 plus 3. And the first thing that I want you to tell me is the transformations. So can somebody who has not spoken yet, give me one transformation here? Right 2. And Avery, what's the other transformation? Up 3, that's right. Good, so we got right 2 and up 3. Okay, so now we have to graph this function, okay? And how are we going to graph this? Does anybody know what we would do to graph this? What do you want to do? Make a graph. How to do that, though?
Sorry, a little T-chart.
A T-chart?
X.
Okay, but even if I did that, do you know any of the points for this graph? No, so we can't do that yet. What can we do?
I should change it back to a normal form.
Right, we're going to change. Okay, so I want to make sure you understand this. Right, you don't know any of the points for this kind of function, right? Log base 2 of something, right? But you do know you can find the points for an exponential function, right? But it's not just enough to change this into exponential form. What you're trying to do, your goal is to find the inverse of this parent function, right? Changing to exponential form is just one of the steps to get to the inverse, okay? So don't mix that up, all right? So what's the parent function of this whole equation? What's the parent of this? I don't need the whole thing. Log of base 2 of x, right. The parent function is just log Whatever your base is of x. And what needs to be in the front, though? Not f of x if we're trying to find the inverse, remember?
G of X.
Not g of x. It's simple. Yeah, y equals. Remember when you're finding the inverse, you have to switch x and y, right? So we're going to rewrite it with a y. Okay, so we're trying to find the inverse because that will give us an exponential equation that we can find points for. Okay, so the first step in finding the inverse is to change this into exponential form. So how do I change this to exponential form? What would this be in exponential form?
2x.
That would be the very final answer. You're giving the complete inverse, right? But you want to be able to do both, like, in sequential order, so that way you can answer both types of questions. You know what I mean? If I were just to ask you, can you change this to exponential form, and you gave the inverse, that wouldn't be the right answer, right? So how do I change this just to exponential form? What does a log statement say if you just change it to exponential? Remember, we had a quiz over this and you guys did pretty well. What is the base? 2. What the? The base is 2. What is it raised to? What's the exponent here? Is it the x or is it the y? It's the y, that's right. And that equals the x, right? There you go. That's exponential. Okay, these two are the exact same thing. There's no difference between what they say. The only difference is the form, right? And like I said, this is just the step that we take in order to get the inverse. That's only the first step. What's the second and last step to get the inverse? Flip the x and the y, so it ends up being y equals 2 to the x. Okay? So this first step where we went to 2 to the y equals x, that's changing forms. Okay? Then when we switch the x and the y, we end up with y equals 2 to the x. That's the inverse. Notice how these two equations are completely different. Right? That's not going to be the same thing at all. All right, so now we found the inverse, and we can use that to help us find points. How do we find points here? We make a table. However, when you're doing transformations, guys, you only need 3 key points, and it's going to be at -1, 0, and 1. Those are the key points. Obviously, if you use -2 and 2, you'd have more information, but for transformations, you really only need 3 key points. Okay, how am I going to find y values here, though? Right, it's going to be y equals 2 to the x, so whatever 2 to the x is. Okay, so if I replace the x with the 0, what do I end up with? 1. Right, 2 to the 0 is always going to be 1. You always, in the parent function, have the point 0, 1. Okay? So if I put in the 1 for x, what do I get? And so if 1 gives me 2, -1 is going to give me 1/2, right. Now what do I do with these points, these values? We flip them. Why do we take the inverse of this? Do you know why we take the inverse of this? Because right now, we just found the chart for y equals 2 to the x, right? Is that what we were trying to graph? Y equals 2 to the x? No, we were trying to graph y equals log base 2 of x, right? And that's the inverse of y equals 2 to the x. So that's why we take the inverse after we found those points. We just find those points to help us get some values because we don't even know where to start. So what is my new x values? 1/2, 1, and 2, right? What are my new y values? That's right. Okay, so that's going to be that is the parent function point for y equals log base 2 of x. Now we're going to apply the transformations to the table and get our final graph. So first transformation, right 2. What does that do to our table values? Mm-hmm. Adds 2 to the x's, that's right. So what is 2 plus 1/2? 2.5, right. What's 2 plus 1? 2 plus 1? 3. And what's 2 plus 2? 4, that's right. All right, our other transformation is up 3. What would that do to my table values? Wait, what? What are you saying? You mean the y values over here? That's not 2. That's just the y values, yeah. Right, so we add 3 to the y values. Okay, there it is. So what are my new y values then? 2, 3, and 4, that's right. And so we're going to graph this. We have 2.5, 2. That's over 2.5, so like about here and up 2 right here. We got 3, 3, that's right here, and then 4, 4 right here. Okay, so look, there's a right way to graph these and the wrong way, right? You have to connect it so where it actually looks like what the graph is supposed to look like. If you mess it up, you'll do like something like this. Like this. All right, you're definitely trying to cheat there. That's not how it is. That's not how it looks. Okay? Because logarithmic is supposed to be the inverse of exponential, which means it would actually end up looking like this. Something like this. All right. So now we have a few more things to find out here. What is the asymptote of this graph? Is it 0? That's right. It's x equals 2. How did you tell that it was 2, Trey? Because you see that it's, because you're just looking at the picture and you see that it's getting near 2, but it's not touching, right? That is right. But can you also tell how you have x equals 2 just from the transformations? The transformations tell you what it's going to be. It went right to, right? Because look, Jaime, you said x equals 0, right? That's the starting one, right? It always starts at x equals 0. But then, based on if it moves right or left, that's going to move your asymptote too, right? Because if we move our graph to the right 2, we add 2 to the x's. Same thing to the asymptote. If it's x equals 0 to start with, and we add 2, it's going to be x equals 2 now. Can you write the domain now in set builder? How do you start set builder?
A bracket.
Right, the squiggly bracket. X.
One.
The line.
X.
X. Greater than 2, that is correct. Now, when you're doing exponentials and logarithmic functions, the asymptote gives you a big hint for either the domain or the range. The asymptote here is x equals 2, right? That, it says x. That means it gives you a big hint for the domain, right? So the domain, you literally write the exact same thing as the asymptote because that's the cutoff point. And you just got to tell if it's greater than or if it's less than that asymptote. And in this case, you see our picture of the graph, right? Is to the right of our asymptote, which means it's greater than 2. What's the range going to be? Negative infinity? Greater, like this?
Less than y.
Yeah, think about what you're saying. How can negative infinity, the lowest thing possible, be greater than y? Yeah, less than y, and then?
Less than
That's correct. And there it is. So that's how you're going to write the negative infinity to positive infinity in set builder. And that's the end of our first example. Our next example is going to be f of x equals negative 2 times log base 3 of x. So first things first, I want you to give me the transformation. So can somebody give me one of the transformations here? What's the first one? Right, reflect over the x-axis. So rocks. And what is the second transformation here? By? That's right, vertical stretch by 2. There we go. Those are our only 2 transformations here. So now we need to graph, right? So I don't know any of the points for log base 3 of x, but what should I do now? What are my steps in order to find some values for my table? Make it exponential. So if I just change the form, that's going to give me my values. We're looking for, what are we actually trying to do? Switching to exponential is part of the steps to get to the final goal. But what's the actual goal here? Right, to write the inverse. Okay, the inverse of the parent function of this, right? So what is the parent function of f of x equals negative 2 log base 3 of x? What's at the beginning? Y equals? And as you said, log base 3 of x. Right, remember it's everything except the transformations. So without the transformations, it's just log base 3 of x, right? That's the parent function. Okay, so now we're going to find the inverse of this. What's my first step to find the inverse of this? Right, we're going to change to exponential form. So what's the exponential form? 3 to the y equals x. Good, nice. And then, now we only need to do one more thing to find the inverse. What is it? We switch the x and the y, so we end up with y equals 3 to the x. There we go. So now we can find some values here. So what were the x values that I told you we can use for transformations? Right, negative 1, 0, and 1. And how do I find my y values? Right, y is going to be 3 to the x. Good. Okay, so when I plug in 0 for x, what do I get? 1. It's always the same. When I plug in 1 for x, what do I get? 3. So look, it's different than last time because our base changed. So if I plug in 1 and I get 3, when I plug in negative 1, I should get 1/3. Very good. And what do I do next after I've gotten these table values? Inverse, right. And so, what's my new x's?
1/3, 1, 3.
And what are my new y's?
Negative 1, 0, 1.
Negative 1, 0, and 1. Okay. So now let's apply these transformations to our table. First, we have reflect over x, and what would that do to my table values? Make the x negatives?
The y.
So we got one person saying the x and one person saying the y's. What do you think? Think about it. Because you want to be able to think through it when you get to a test, right? Because even if you didn't remember right away, if you understand what's happening here, picture it. Reflecting over x, how does it reflect? Yeah, because it goes up and down, so that means it's going to change the y values, right? Like if you imagine something reflecting over the x-axis, it's like this, right? That's up and down, so it's going to be the y values. So all the y values, you're going to change the signs on them. So instead of negative 1, you have 0 doesn't have a sign, so 0, and then positive 1 turns to negative 1, right. The last transformation you have is vertical stretch by 2. What does that do to the table? Which one? The y's, right. Why do you say that? Because vertical, that's right. Vertical stretch by 2. So you multiply all the y's by 2, and what does that make my final y's? 2? 0? Negative 2, right. So let's graph this. We got 1/3, 2. That's about right here. Then we have 1, 0, and 3, negative 2. And when you connect these points, they should look something like this. Right, okay, so what is the asymptote here? X equals 0, right. There was no left or right movement, so it's just going to stay where it starts, which is x equals 0. Make sure you actually draw the asymptote with the dashed line and the arrows on your graph, okay? Because that's going to be part of what you're tested on as well, to be able to draw an asymptote. All right. What about the domain? Let's do this interval notation this time. Can you give me the domain and interval notation? That's set builder. So what's interval? x is greater than 0. Okay, that's just a general way to write domain, which if that's right. However, if you wanted to write interval, what would it be? From where to where? 0 to infinity. Very good. That's interval notation. X is greater than 0. Yeah, that's a general way to write it. It's very easy, simple. But interval notation is going to be parentheses 0, comma, infinity, parentheses. Going from 0 to infinity. And why is there a parentheses around the 0? Right, because it never reaches 0. It's just getting closer and closer to 0. What's the range going to be? And what are my symbols around those? Parentheses. There we go. Nice. And that is it. The last section of notes for Unit 9 Test Wednesday. All right. Well, until next time, see you guys.